What kind of buttons do you some of them are boxer flaps, some of them are boxer doodads.
Okay, here, shh. This says the square root of 5x plus 1 is equal to 4, and we're told to solve for x. Okay, now we're going to have several steps to consider when we're doing this. First step is to isolate the radical. Remember, the radical just means the root symbol. So we want to have nothing except for what's underneath the radical on one side of the equal sign. So we got that right now. Like, we're going to see some in a minute that's got extra junk. But right now, all we got is underneath the radical on that side, so we're good. Second step after that is to get rid of the radical. In this case, it's going to be a square root, and the majority of them are square root, but some of them will be cube roots, some will be fourth root, or whatever. So how do you undo a square root?
By
Squaring it. Good. So we're going to square, like I said, both sides, square that whole thing. Okay, now when I square here, the square and the square root cancel each other out. So that'll just be 5x plus 1. The other side, this one's an easy one because it's just a constant there. Sometimes we'll have to do some foiling and stuff, but right now it's just 4 squared, which is just 16. So that just made an easy 2-step middle school equation to solve. What are you going to do first? Subtract 1. 5x is 15, so then you divide by 5, so x is 3. Go back and check it just to make sure. You can do that just mentally. 5 times 3 is 15, plus 1 is 16, square root of 16 is 4. So you can circle it, that's good. Easy stuff there. Okay, this one, I've got the square root. Whoa. Usually I don't start doing this till late today. Got the square root of 5x plus 3, and then plus 2 is not underneath there, is equal to 0. Not yet. Remember I said we got to isolate the radical, so we need to get rid of extra junk. Okay, so it's being added, so to move it over there we would subtract it. So that gives me the square root of 5x plus 3 equals negative 2. Now, I'm going to tell you right now, based on that, I know that this has no solution. So I would stop if I were doing this on my own. Do you see why I know that? We can't have a square root of anything that equals a negative. Because something times itself always equals a positive, right? Okay, so...
Unless there's a positive constant.
No, it wouldn't matter.
Doesn't matter.
Yeah.
I got 5.
Alrighty. This one we've got says, whoops, square root of 5 minus x is equal to x plus 1. Okay, is that radical isolated? Is it the only thing on the left side? Yeah, so we're going to go ahead and undo it now. It's a square root, so we'll square. We square the square root, that cancels out. But here when I square, that's a binomial. So I can't just write x squared plus 1. I can't just square them both. That means I have to write the binomial twice. So that'll get me x squared. My outer is 1x and my inner is 1x, so that makes 2x. And then my last is 1. Alright, so now since that's squared, that's a quadratic. What do we try to do when we're solving a quadratic? Yeah, but we got to do something before. Good, we need to set it equal to 0. Good. So I'm going to subtract 5 from itself and its buddy. And since this x is being subtracted, I'm going to add x to itself and its buddy. So that's going to get me, that'll cancel out. X squared plus 3x minus 4 is equal to 0. Now, we got choices on how to solve this. Based on the book that we're in now and the progression that we're doing, you would be doing what Blake said and factoring it, because this year we've not gone over the quadratic formula yet. But you know the quadratic formula from Algebra 1 and Algebra 2, so you could do the quadratic formula if you wanted to. I prefer factoring when I can, and this can factor, so I'm going to do that. Reason I know it can factor, I do my a times c. 1 times negative 4 is negative 4. The factors of negative 4 that add to 3, 4 and negative 1. So this would factor as x plus 4 times x minus 1 is equal to 0. Now you just set both of those equal to 0 and solve. If x plus 4 is equal to 0, that gets you a negative 4. And some of y'all already know that and skip this step. If x minus 1 is equal to 0, that gets you a 1. So the answers I'm looking at are negative 4 and 1. Okay, let's go up there and check those. If I plug a negative 4 in here for the x, 5 minus negative 4 is 9. The square root of 9 is 3, so I'll get a 3 there. Over here, negative 4 plus 1 is negative 3. 3 doesn't equal negative 3. So my 4 gets thrown out. It's no good. Okay, let's plug the 1 in. 5 minus 1 is 4. The square root of 4 is 2. 1 plus 1 is 2. So 2 does equal 2. So 1 is the only answer this thing has. X equals 1. Write it bigger so we can see it. We're ready? Okay, I've got square root of 1 minus 2p minus p squared is equal to p plus 1. So the only thing that's different in this one is that underneath the radical it's a trinomial now. But your plan of attack is still the same. Is the radical all by itself on the left? Yes, so we don't have to move anything. Now we just want to get rid of the radical. How do I undo a square root? So we square everything. Even though it's a trinomial over here, that squared still just cancels the square root out. 1 minus 2p minus p squared. And when I square p plus 1, got to write it twice and FOIL it. I think that's the same one you just had, so you should just change the p to x to a p, so you should have it, right? Okay. Now, this one is cool. I kind of like this one a little bit. I need to set it equal to 0, so you can move stuff on whichever side you want. I'm going to get rid of the stuff on the left because a lot of that's being subtracted, and I like to add. So, but the 1, I'll have to subtract it. Subtract 1 from itself and its buddy. 2p is being subtracted, so I'm going to add 2p to itself and its buddy. P squared is being subtracted, so I'm going to add p squared to itself and to its buddy. So it gets me 2p squared plus 4p, and that constant canceled. So I can put a plus 0 there if I want to. I'm not going to. I'm just going to say equal to 0. Only reason I would ever put a plus 0 there is if I needed to do the quadratic formula and I needed to know that my c was 0. But I don't care about that now because I'm just going to solve this. This is why I said this one's a cool one. This one's easy to solve because my factoring, it's not a trinomial. So I'm just looking for a GCF in this thing. So I take a 2p out. That leaves me with p plus 2. Now I just set both of those equal to 0. If 2p is equal to 0, that means p is equal to 0. If p plus 2 is equal to 0, that means p is equal to negative 2. Now, I'm going to check the negative 2 first, because I want you to see that we already know it doesn't work. Not just because it's a negative, but because what we add it to leaves it a negative. Negative 2 plus 1 is negative 1. So that can't be equal to a negative there, right? We talked about that earlier. So I know that that one's not going to work. You can go ahead and plug it in for all of it if you don't trust me, but 0 plus 1 is 1. Did the easy side first. Over here, this is easy too, because 2 times 0 is 0. 0 squared is 0. So I just got 1 minus 0, which is 1. 1 does equal 1, yep. So 0 is your answer. Woohoo! Alright, this next kind that we're going to do is the longest kind of the day. I got the square root of 2x plus 3 plus the square root of x plus 1 is equal to 1. Alright, our first job on all of these have been to isolate the radical. And on the left side right now, you've got 2 pieces that have a radical. You got to get that down to 1. So we got to get rid of one of those radicals. So I'm just going to subtract, since this one's being added, I'm going to subtract that one. Whatever I do on one side, I got to do on the other side. So that'll cancel out over here. I've just got the square root of 2x plus 3 is equal to 1 minus the square root of x plus 1. Okay, that let me get that radical on the left by itself. But that means I'm going to have some ugly work on the right here in a second. Radical by itself is a square root, so we're going to undo that by squaring. Easy there, just cancels out. Now this gets a little bit fuzzy here. When we square this, this is a binomial. Because 1 is a piece and the square root of x plus 1 is a piece. So when we FOIL that, I'm going to have 1 minus the square root of x plus 1 times 1 minus the square root of x plus 1. Okay, it's not too horrible, it just looks all goofy. On your first, you get a 1. On my outer, that's 1 times the negative square root of x plus 1, which is just the negative square root of x plus 1, right? Because 1 times it doesn't change it. Want me to write that down? Negative square root of x plus 1. And on the inner, it's the same thing. A negative square root of x plus 1 times 1. So again, that's a negative square root of x plus 1. Now those are like terms. How many of those do I have? Negative 2 of them. So minus 2 square roots of x plus 1. Now my last, I got a negative times a negative, so that's a positive. Square root of x plus 1 times the square root of x plus 1. If I have the square root, I think Valentina might just said, if I have the square root of x plus 1 times the square root of x plus 1, isn't that the same as the square root of x plus 1 squared? So I want the square and the square root cancel out, so I'm just going to have x plus 1 left over there. Alright, let's see on that right side, I got a 1 and a 1. That's about all I can combine, isn't it? So it's going to be negative 2 square root of x plus 1 plus 2 is equal to 2x plus 3.
Plus x.
Yes, thank you. I missed that plus x. Okay. Now, we started off with 2 radicals on one side, and we moved one of them over, and we got rid of that radical that was left. So now this radical, we got to get it all by itself, so we can get rid of it. Okay? So I would subtract a 2 from itself and its buddy. I would subtract an x from itself and its buddy. So that's going to give me x plus 1 is equal to negative 2 square root of x plus 1. Get off there, you stupid boxes. They're not there. Y'all are the lucky ones. This usually only happens in the afternoon, so y'all never had to deal with this. Come on, stay.
So close.
Alright, so where we are now, a lot of people will look at that and they'll see that negative 2 there and they'll want to divide by negative 2, and you could, but none of the stuff on the left side is divisible by negative 2. I mean, it would still be a fraction. So I'm just going to go ahead and leave it there and square it like it is. Okay, because we're trying to get rid of that square root now. So we're going to square everything. I'm just going to write on the board. Sorry, I'll be in front of some of y'all that tell me to move and I will. Alright, so when we square that, that's FOIL. So we've had x plus 1 all day today. Y'all ought to have that by now. That's x squared plus 2x plus 1. Go ahead and FOIL it if you don't remember. When we square here, that's not a binomial because there's no plus or minus sign in between the 2 and the radical. So we can just square that negative 2. And then when we square that other part, the square root cancels out. Okay, so distribute your 4 where you lost it.
Well, I don't know. I thought that we already did that, but then we didn't.
Well, because remember, look at the top. This one had 2 radicals.
Okay.
So we're on the second radical now.
Okay.
I know.
It's long.
Yeah, these are the long. That's why I said this is the longest kind today. We're ready to distribute that 4, right? So we got x squared plus 2x plus 1 equals 4x plus 4. Since that's the side I'm taking notes, it'll be easier to stay on this one. Yeah, but you're back there. Like, I was standing right there as blocking Reed, but Debbie's not watching, so it's okay to block this. Alright, need to get it set equal to 0 now. So I'm going to subtract the 4x from itself and its buddy. And I'm going to subtract the 4 from itself and its buddy. So that'll give me x squared minus 2x minus 3 is equal to 0. We can factor that. Factors of negative 3 that add to negative 2. Negative 3 and 1, so we would have x minus 3 times x plus 1. Okay, we're almost there. X minus 3 is equal to, why did they come up in our rising? Got a 3 and a negative 1. Yep, we're going to check them both. Alright, ready to go scroll up and check them? Some people are still getting that. Let me wait a minute.
You gotta scroll up. It's so long.
It's a scroller. Wow. Alright, let's scroll up. We got a 3 and a negative 1. Alright, 2 times, I'm checking the 3. 2 plus 3 is 6. 6 plus 3 is 9. Square root of 9 is 3. 3 plus 1 is 4. Square root of 4 is 2. Does 3 plus 2 equal 1? Nope, so 3 is no good. Alright, what was the other one? Negative 1? 2 times negative 1 is negative 2. Negative 2 plus 3 is 1. Square root of 1 is 1. Negative 1 plus 1 is 0. Square root of 0 is 0. Does 1 plus 0 equal 1? Yep. So, -1 is your answer. Now, let me give you a glimpse of good. We still got another one to look at, but let me give you a glimpse of good news on that, because this is what Katie will enjoy hearing. Your test is multiple choice. So you could just look at the choices and plug them in and see if they work.
That would be what I would do.
That'd be good.
Because that,
Yeah, that would be me.
that would for sure be me.
Coach, I'll do it like this for you.
I appreciate it, Blake.
No way.
Alright, the only thing we haven't looked at is when it's a different root other than square root. So let's do one of those real quick. I got the cube root of 2x plus 7 is equal to the cube root of 3x minus 2. Okay, now when you first look at this one, you're going to look at it and say, well, that's got 2 radicals. That last one had 2 radicals and it took 18 pages to do. This one is not as long because there's no extra junk. So we don't have to move extra junk over that. It requires that foil and all that. When we cube root, there's no extra junk. So the cube roots, and I said when we cube root, I meant cube. When we cube, there's no extra junk. So the cubes and the cube roots are going to cancel out. We don't have to foil because there's no extra junk. Does that make sense? Okay, so it's being cube rooted. It's already told you to get rid of a cube root. You cube. There was no extra junk here. So that cube and cube root cancel out. You just got 2x plus 7. Same thing here. There's no extra junk. So the cube and the cube root cancel out. You just got 3x minus 2. Solving for x. What do you want to do first? Say it again, Kelsey.
Yeah.
Subtract 2x. Thank you, Angie. So 7 equals x minus 2. So what's x? Now do got to check and make sure, because it could be no solution, so I still got to check it. So 2 times 9 is 18. 18 plus 7, 25. Is it?
25.
I think 87 is 15, so
Oh, yeah,
25. I don't know. 25 is not a perfect cube. Don't panic on that. That doesn't mean you're wrong. We're just going to know that this stays a cube root of 25. Because I could get a cube root of 25 over here. If I do, it works. If I don't, it's not right. 3 times 9 is 27. 27 minus 2 is 25. So I got the cube root of 25 and the cube root of 25. That's the same. So that works.
I feel like we earned some fried Oreos for breakfast.
Fried Oreos. That doesn't even sound good to me.
No, have you never been to like the fair or something wrapped in fried Oreos?
No.
Oh my goodness, they're so good. Have you ever had deep fried they're like cheesecake? They're like egg rolls, but they're cheesecake and they're covered in powdered sugar.
Ooh.
That's an AP music theory teacher.
Alright, what we've got still on the horizon. Tomorrow is complex numbers. That means the I's, imaginaries that y'all been talking about. We'll look at that tomorrow. Thursday, y'all listen. Thursday, we're going to have an assignment over the whole chapter. And then Friday, we'll get our study guides. We'll do those Friday and Monday, and the test will be Tuesday. So a week from today will be our test. Okay? Are good?
Yeah.
Alright.
Next Monday.
I think that's...
It is 9:30.
Yeah.
So the test will be Tuesday.
Yeah. You'll have your study guide. If you can't get it checked, then you can watch it on YouTube.
Because I'm going to like an experience of yours thing, and I'm going to fill out my presentation here in yours.
It'll be fun.